Hello, everybody. These are the video guided notes for lesson 1.1. Now, every time that you're doing the video guided notes, here's what you need to do. You need to have your paper. If you have graph paper, that's best. But if you don't have graph paper, that's okay, because you can also use lined paper or printed paper. Eventually, we'll have a specific type of notes paper that you'll get. But for now, just use what you have. Make sure you have your pencil or your pen. And actually, if you have colored pens, I really like to use the colored pens for the notes because then I can color code the concepts. And then what you want to do is whatever I'm writing on this piece of paper, you want to write on your paper as well. And you can pause or rewind or rewatch any part of the video at your own pace. When you're done with all these notes, once it's all complete, then you make sure that you take a picture of it and you're going to submit it on Google Classroom so you can get credit for taking these notes. Okay, here we go. So make sure your name is in the top right. We always start our notes by titling them at the top with the lesson number. So this is going to be the notes for lesson 1.1. And it's 1.1 because it's module 1, lesson 1. And these notes are going to be titled Function Notation. So what I want you to do is we're actually going to draw a function machine. So in order to do that, what you have to do is just draw a rectangle. It can be about this big. Size doesn't have to be too specific. We're going to draw a little valve where numbers can come in and a valve where numbers can come out. Numbers that go in, we're going to call that the input. So the number that goes into this box is the input. And then the number that comes out of the box, we're going to call that the output. And I'm going to use the variable n to represent whatever number comes into the box. And then I'm going to use the notation f of n to denote whatever comes out of the box. And in this case, this magic box, here's how it's going to work. Let's make a table on the right here. And we're going to put our input numbers on the left and our output numbers on the right. So f of n on the right. And now let's say we start with the number 0. So 0 comes into this magic box, something happens. And then after something happens, the number 3 comes out. Okay, so 0 was the input, 3 was the output. Now let's say we put in the number 5. 5 goes into this little function machine, something happens, and out comes the number 8. All right, and then we can pick any other number. Let's just say the number 21. 21 goes into the function machine, something happens, and then out comes the number 24. All right, so now you might be thinking to yourself, what is happening inside this function machine? Well, it looks like whatever comes in, whatever comes out is 3 more than that. So what math operation is that? We're adding 3. That means what this function is we can say f of n is equal to whatever the input is, n is whatever we put in, plus 3, and that's how we get to the output here. Right? So this is our function. Okay, so this is one example. I'll put that one over here. I want to show you another example of a function. So let's say I'm being asked to evaluate the function f of n is equal to 7 plus 5n when n is equal to 10. So what this is saying is, when this is my function, right? When my machine is doing 7 plus 5 times whatever number you put in, right? N is the input. Well, what would the function be? What would the output be when my input is 10? Right? So you can imagine you're putting 10 into the machine. It's getting multiplied by 5 and then added by 7, and then another number comes out. That's what this is saying right here. All right, well, let's write it out. So we have f of, now instead of n, we're actually going to put the number that we're inputting in. We're putting in 10. So now instead of f of n, this is f of 10. So the function of 10, that's what this is saying, is equal to 7 plus 5 times n. But instead of n, right, we're putting in 10 because we're making n equal to 10. The input is 10. So this is now 5 times 10. Because 5n means 5 times n. So now it's going to be 5 times 10. So then I can say f of 10 is equal to 7 plus 5 times 10 is 50. So then I can say f of 10 is equal to 7 plus 50 is 57. So to bring this all together, when the input of the function was 10, the output of the function is 57. I can say f of 10, the function of 10, is equal to 57. All right, last thing that I want to show you is a third example of how you might see a function. And sometimes you might just have a table. So let's make a table. And sometimes tables can go horizontally. So let's try that. So let's say my first three inputs are 0, 1, 2, like that. My first three outputs are 13, 19, 25, like that. So you might have a problem that says something like, when n equals 2, what is f of n? So this is saying when the input of the function is 2, what is the output? Well, I can just look at the table. So when n is equal to 2, I find that that's right here. Well, f of n, the output, is in the table right there. So then I can say my answer, well, f of 2 is equal to 25. Another way you might see this question is when f of n is equal to 13, what is n? Another way of thinking about this is when the output of the function is 13, what is the input? Well, I can go to the table. Okay, so I'm looking for when the output is 13. When f of n is equal to 13, that's right there. Well, what is n? Right there. N is 0. So I can say n is equal to 0. All right. And those are your notes for function notation. You're going to use these notes to do your first set of 1.1 homework. Don't forget, when you're done with this, take a picture of the whole thing and post it to Google Classroom so I can give you credit for those notes.